Before making the board and etching it, I decided I didn't want to do the G3UUR again. So let's do a new project. We'll call this number 2. We're going to do this simple audio amplifier. This is out of Wes Hayward et al.'s book, Experimental Methods in RF Design. Get it from the ARRL if you don't have one already. It cost $49.99, I believe, plus shipping over $10. I tried to buy a copy today, but the ARRL didn't like my credit card, so I have to call them tomorrow and work that out. But I scanned my copy in a long, long time ago, and I no longer have it, but I just need to get a hard copy. Here we go. So we're going to do this. I already did this amplifier Manhattan style, and it looks like this. Looks pretty complicated, but if you go look at my Manhattan videos, describe the process. And this is not for everyone, well, nothing is, but let's try this with the new toner transfer. Now, I already laid out one board using 1/4 watt resistors, and I put the resistors vertical, and it turns out that the board is going to be just too tight for a new person to try. So I came back and relayed it out using 1/8 watt resistors. Now, I love the 1/8 watt resistors because if you go to AliExpress and search for 1/8 watt resistor kit, you'll get a lot of possibilities, but I like this one here. I bought a set of these resistors, but these are metal. The ones that I bought were carbon, and this is in a Dollar Tree container, and the carbon resistors are brown. It's about 5 millimeters across here, and fortunately somebody sits down and writes. You get 20 copies of the same values, and there's 64 values, so that makes about 1,200. Anyway, if you go and look here, and this is, you can look for this item 325680311210517.html. Now this company has sold 11 of these, has a 5.0 rating, and you get free shipping. And these values are stamped. Now the metal resistors are 1% value, and if you go down here and look at this table, the values start at 1 and go to 10 megs, and I looked and there's 10, there's 33, 47, there's 100, 150, 220. I'd like to see 200, but 220 is close enough. 330, 470, 4.7K, 10K, 47K, and 100K. These are most common values you'll use. So some of these you probably won't ever use, but better to have them and not need them. So there's a possibility there. I'm always trying to figure out a way to spend your money. So here's what I did. Now this program, Sprint Layout, runs under Linux using the Wine program. So let me go File, Open, and what did I name it? I named it EMRFD Open. So this is what the board layout looks like. Looks pretty complicated. Let's go back to the schematic and let me minimize this. Go over here put it over here on the side. Now, the way I do this is I just go left to right, and so here's the 2.54 millimeter header. I use the headers for input, power, and output for experimental stuff. I'll show you when I get it built. Now, first thing we go is R1, which is 3.3K, and there it is. Then there's C1, and etc. And you can look at how you can stop the video and look yourself how I did this. The only change that I made is I always, in my circuits, use a reverse polarity diode, but here, this circuit will work from 5 volts to plus 12. So I put a little LED in here. Here's where the VCC comes in. Grounded on this pad. Goes through an LED, and this, if you hook the battery up or power supply up backwards, nothing happens. So it'll save you some transistors from once in a while. And then some more expensive stuff later on. So always use a diode or an LED or something to protect this. And I'll give you some more later on, other tricks. So, and then I made one other mod. Whoops, let me kill this off here. On the output, going back to this circuit here, the output goes to the capacitor, and then the audio out from the amplifier goes through this coupling capacitor out. And I want to test this thing, so I added a load resistor here, and I'm going to put 8 ohms here and 16 ohms, 8 ohms to emulate a speaker, and 16 ohms to emulate earbuds or whatever. And we're going to test this thing. There's not too much in the book about the capabilities. I'll let you read that, and we'll come back and discuss it. Now, now let me kill off the silkscreen layer, and this is what the board looks like from the top, and this is on the bottom. I'm going to go and put the gloss paper in the printer, and then I just go over here to print. I don't want the silk screen. I don't want the upper layer. So I just want the bottom copper layer, and this is what it looks like. And I can move it down a little bit so it's not right on the edge of the paper. And then I just hit print and it goes off. I also have the capability of sending it to a file if I activate my PDF printer. And that's how I put the PDF file out on my web page for the Project 1. I'm not going to print this off right now. So that's how I do it. So I want you to, one, look at the schematic, and if you want to, get the program and figure out a layout yourself. I'll show you a little trick. One of the things is remember the drill size, bit size, that I had some of the pads here had a larger opening, so I just go and set them all to the same size. The way I do that is go and activate the whole board, and over here there's the pads, there's the hole size. Let me go and make this like 0.6, which is way too big, and you see all the holes get larger. 0.5 is probably the good size, but I'm going to make it 0.4 so that when I use the drill press, the bit will pretty much auto center, and it'll be all centered, and then come back and drill out the 1, 2, 3 headers for larger. Another thing is that the only capacitors used in this circuit are electrolytic. There's a 4.7 microfarad. There's another 4.7 microfarad. That's 100 microfarads and 100 microfarads. All my electrolytic capacitors, which I got from AliExpress, are 2.54 millimeter spacing. So that's my spacing here for these capacitors. Okay, I think I covered enough to get you entertained as to what we're doing. Did this in less than 11 minutes. So, study this, and I'll come back tomorrow and we'll build a board. Thank you for your time. Thank you for the likes, and I'll talk to you tomorrow.